That's me right now. I went to bed too late. That's my problem. Okay. So we have this. I would like to explain again why we did everything we did yesterday, because y'all were really good sports, and you wrote everything down, but I feel like you were just sort of trusting me that we were doing this thing, and I wasn't sure it was clear why we were doing it. So real quickly, you don't have to write this down, but we started out by me talking yesterday. This is one of the basic log functions. And I said the domain, remember domain is x values that work for the graph. And the domain is 0 to infinity. So all the positive x values work. This graph will never actually reach x equals 0. So we put a parenthesis there on 0. And I said, okay, that's good. But what if this graph was transformed somehow? Like if it got pushed to the left 2 places, it would become this blue stuff right here. Right? That's a horizontal shift to the left. And the graph itself, the vertical asymptote would shift to the left too. And then the graph would shift. Now my question is, what is the domain now? Where does the domain begin? It begins there at -2. That's where x equals -2 is. So the new domain for that shifted graph doesn't start at 0, it's -2 to infinity. So it now covers all these things, right? And so what we did yesterday was I gave you equations that weren't just simple transformations. Because if they were just simple transformations, left, right, up, and down, we would just think like that and do the domain from there. They're harder to sort of figure out. We can't easily graph them. So what I did was give you an algebraic method and a systematic method for determining the new domains on other kinds of things, right? And this was the method for that. I first pointed out that the domain for logs can never equal 0 because it will never cross at x equals 0, and it has to always be positive. So that's 2 conditions that have to be met for any x value that's going to go in here. X can't be 0, and it must be positive. And again, algebraically, so on a graph that's clear, but algebraically that's also, it means this entire thing, whatever this value is, we can't take the log of it if it's 0 or negative, okay? So we're going to deal with these 2 conditions separately. Here's how we take care of the first one. Okay, the domain, it can never be 0, whatever you're taking the log of. So this thing right here can never actually equal 0 because it doesn't work. It would be undefined. And so we set that up and we solve by adding 36. X squared cannot equal 36, and I square root both sides. How many answers does that give me? 2, positive and a negative version. So far I know that of all the possible x values in the world, at a minimum, positive 6 would be bad, because if I put positive 6 in here, what do I get? 36 minus 36, which is 0, and I can't do log of 0. And negative 6 would be bad. But I need to figure out what other numbers are bad. And the way I do that, so that's the second part, where we figure out which x values that if I plugged it in here would keep this a positive output, would be a positive value. And what did I say to set up to do that? A number line. Okay, the number line represents all the x values. I know that it can't be -6 or 6. But I have all these other numbers to the left of 6, all these numbers between here, and all these numbers between here that might be okay. Now, there's no way I could possibly test out every single one of those numbers. So what I do is 1 test point in this range, 1 test point here, and 1 test point there. And that's my representative. It represents all the possible numbers there. So give me a test value that's to the left of -6. -7? Okay. So I take that and I plug it in just to the x squared minus 36. Remember, I'm not actually taking the log of that number. I'm just seeing what the domain is, what x values will keep it positive. So I plug in -7 to the squared thing. Remember your parentheses around the -7. What is -7 squared, quantity squared? Positive 49, right? Please don't put -49 there, that's bad math. So 49 minus 36 is 13. I don't really care that it's 13. I care that it's what kind of number? Positive, right? So positive is good. So I don't have to test any more numbers in that interval. I already know everything there is going to work. By the way, because of the squared, if negative 7 gives me 13, what other number would give me 13? Positive 7. Like if I were to check positive 7 over here, that's going to give me the exact same thing. So we know that this will work. And so the last thing we need to check is that middle interval. What's a good number to check there? 0. So I put that into the original expression. That gives me negative 36. How do I feel about that number? I feel negatively about that number. So then I've got, so that middle interval does not work. This one works, this one works. Why is that not my final answer? Perfect. I need to put the intervals in interval notation. And that's a left boundary and a right boundary. So this is negative infinity to negative 6, parentheses, and this is 6 to infinity. One thing I've seen people do today is if they tested negative 7 and 7, they were putting those numbers here in their answer. But please remember, that's not your boundary endpoints. That's just the numbers you tested. They're arbitrary. So you don't want to put them here. It stops at negative 6 and starts up again at positive 6. Okay. Who got that all correct? Interval notation, everything. Okay. And then who wasn't sure what to do, but now they're good? Okay. Who did the homework? No, you were? Oh, trying to fake me out. Any questions on the homework? Okay. Bless you. So we have this quiz coming up Monday. It's on these 3 days. Now look, y'all. Last week I did this. Last Friday I said you got a quiz on Monday, and I put this calendar up here and I highlighted the days, and I was like, you're gonna have your notes. And so then Monday came along, and I spent the first 5 minutes of quiz time trying to tell everyone what kind of notes to find. And I rethought my entire life choices about being a teacher. I almost just left. I didn't really do it. But I was like, y'all. That's what I was thinking in my head. Y'all, come on. This is Friday. You have like 3 days. We are in 24 hours times 3 before we're back here. I am pretty sure you can get your notes in order before then. Okay? So, and then if you... Yeah, we can use our notes this whole unit. Okay. So today's lesson, we do have a new lesson today that's not going to be on Monday's quiz. All right. So just these 3 things. And no old stuff, unless it just happens to be a skill we need for the new stuff. So questions about what's on your quiz Monday? Yes? This is a long unit. Yes, and because there's no good like breaking up, since they're related to each other, logs and inverses, there's no great place to just break it. So yeah, that's why it's such a long unit. All right, you can read the funny thing while I pass out your notes. I appreciate that. All right, let me say all that again. If you're starting in exponential, you do lasso to get it in log, and vice versa, and then you solve. All right, so here we have this. We're going to start out real nice and simple. We have, what does that LN stand for? Natural log. And what's up with that? What is that about? What does that really mean? Log base E, right? So this is really log, I don't like green, bless you. Log base E of x equals 1/2. So here's the thing. This is not log base E times x, right? This is not a multiplication here. Log is a function that's actually happening to the x. So x is bound up with the log. Excuse me. So we have to get rid of the log by doing the inverse, and we all said that the inverse of log is exponential, and that we use lasso to do that. So we start with the base, we lasso around, and we have e to the 1/2 equals x. Done. Right? Because I got x all by itself. There's nothing else that needs to be undone or done to it. By the way, the directions say solve, and it says write the answers in exact form. This is exact form. But then it says approximate to 4 decimal places. We're not going to do that. We either need tables or the fancy calculators. It's just where you would actually go to the graphing calculator, you put e as a base and 1/2 as a power, and calculate the decimal. I don't really want to spend time doing that. I'm more concerned about your equation solving skills. So don't go to the baby calculator and try and do 2.7 to the 1/2. That's not going to go well for you. You'll just be frustrated. It doesn't work. All right, so that one was, it started in log. We used lasso to get it in exponential, and that's how we solve for x. What form is this one in? Exponential. So we need to do what to it? Log, by using lasso. You try that. Try and rewrite it like that. Are you done? No? So lasso, you're starting with the base. You're lassoing around. It's in exponential. We're going to log. So log base 10 of 0.024 equals x. There's nothing else that needs to be undone for the x, so we're done. How else could I have written this and still been okay? Right, just log 0.024. Because log base 10, you don't have to write the 10, it's understood. That's a common log. So either one of those forms is good. Right, so not too bad. What's up with this one? How's this different? It has several things different, right? This is where we go back to the steps in the beginning of your notes where it said you have to isolate the log term or isolate the exponential term, whichever one you're beginning with. What kind of special term do we have here, log or exponential? Exponential, because there's a base with an exponent. This is the exponential term right here that we need to get by itself before we can do the lasso stuff. So that's just like any time we try to isolate something. What is the first thing I'm going to do? Subtract 2, right? And then after that, I will divide by -3. If you want to see it in a simpler form, pretend that we didn't have the e stuff and we had something like, we just had an x there. And ask yourself, okay, what would I do if it was this easier thing? Oh, okay, I would subtract 2, and then I would divide by -3. And that's what we're going to do here. So -2 to both sides. Gives me this. We still don't care about the exponential crazy thing because we're just trying to get it by itself right now. What do I have to do next? Divide by -3. Bless you. So this is where I've isolated the exponential term. Okay, there's nothing else being added or subtracted. There's nothing else being multiplied or divided. The x is stuck up there in the power. I need to get it down like in the normal level of the equation on the ground, right? Not up in the air in the power. So I do the inverse of exponential, which is what? Log. So that means I need to lasso. So I have log base e of 3 equals 0.4x. I don't have x solved for yet. It's 0.4x. How do I get x by itself now? Divide both sides by 0.4. Those cancel, so I have x equals log base e. How do you think I'm going to rewrite log base e right now? ln, right? ln of 3 over 0.4. You can leave it like this. You do not have to actually do any math because to do natural log of 3, we need the graphing calculators or tables. So this is called exact form. We're just going to leave it like that. Yes, ma'am? No, I won't take off if you just leave it log e. It's correct either way. You take a minute and try this last problem. was a small town, a small country town. All right, so a couple things I want to say here. There was some confusion about when can you handle that 2 times the x and what is the log doing and blah, 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 blah. One thing I want to point out to you is in the wordy steps at the beginning of the lesson, right here, isolate the exponential expression or isolate the log. It means that entire piece of thing, like log of 2x is the entire thing that you're trying to isolate. So this needs to be by itself before we can do the lasso step. This is the same math as if instead of having that, I had this. That you can handle easily. You know that you have to subtract 9 and then divide by -4. And that's exact math we're going to do here. Children. Who's good with that step? I just did the -9. Okay, what do I do next? Divide by -4. What are some weird things you might have tried here because you didn't really understand what log does? Like this log is a function of 2x. Like you can't just, well, I guess what I'm trying to say is, you can't divide by 2 here, for example. Because that 2x is tied up with the log. We have to get rid of the log by doing the inverse, which is exponential. So I'm going to have to do the lasso, but I need a base first. I don't see a base. It's 10. Anytime there's no base written, you know that it's 10. That's assumed. So we start with the base and lasso around 10 to the 1.35 equals 2x. Now, on your baby calculators, you can't actually do that math, 10 to the 1.35, so don't do it. You do want to do stuff like this, 5.5 divided by 4, because that's real easy. That's easy math. You don't even need the calculator. The crazy math you don't need to do because we're not using the graphing calculators. But so it kind of feels like we're done, except that x isn't by itself yet. It's still times 2. So how do I undo that? Divide by 2. So x equals 10 to the 1.35 divided by 2. Okay? Oh, good question. No, it's not 5. You cannot do 10 divided by 2 here because that 10 is got the exponent, all right? It's not by itself. Yes?